you anytime wondered how ADC works, how the temperature sensor works? Let's see how it works in real time with the microcontroller. Hello, embedded learners. I'm Geeta. I work as a technical director for ARM tools at GSAS Microsystems Private Limited. So in this video, I'll be covering on how the temperature sensor works with the microcontroller, how the ADC works and how it can be configured through the microcontroller, any microcontroller. So today I'll be showing the demonstration of these both by using our GSAS LPC1768 microcontroller. So let's come to the hardware part, and after that I'll show you on the software. So in the hardware, I would like to show you what are those main components or the peripherals which are involved for this particular video. So now I would like to explain first the temperature sensor project. Later on we will look at the ADC project. So coming to temperature sensor, our 1768 GSAS board has an onboard temperature sensor which is LM75. Okay, and you also have a 7-segment display here. Both of these are being driven by LPC1768 through I²C bus. Okay, so this temperature sensor will detect this room temperature and it will display the temperature on the 7-segment display. So these are the main components of this particular project. Now let's come to the software. Because as I said, this LM75 temperature sensor and the 7-segment display, which will display actually the temperature, is driven by I²C bus. So before you start writing code for the I²C, you have to keep some things in the mind. Basically, in this case, LPC1768 is your master, whereas LM75 and the 7-segment display, the driver, both are connected through I²C bus. So they act as a slave. So we should always set the slave address correctly for your I²C application. If you fail there, then the I²C application will not work. So the first step you have to know is go to the datasheet of those devices, understand the slave address of those I²C devices, and then enter that in your project. So this sample project is not developed by ARM, it is given by GSAS because the board is being developed by GSAS. So now here you have to modify that slave address. After modifying the slave address, next step is, because I²C is multiplexed with GPIO pins of LPC1768 MCU. So you have to use the registers or for that specific microcontroller, whatever you are planning to program, and configure saying to the microcontroller, use this particular GPIO pins as I²C bus. SDA, SCL lines are the two I²C lines for this application. So after doing that, like here in my project, I'm using this PINSEL register because I'm using NXP, and in NXP you have to configure the GPIO pins to work as an I²C or any specific peripheral. You have to use the Pin Connect block, and PINSEL registers are part of this block. So now let's build this project and download the code. It downloads the code. And now you can see here on the board, you can see there is a temperature. So it's showing the room temperature is 30 degrees. So that is being sensed by the temperature sensor. LM75 detects that. So if you have AC or the coolant, then this temperature may drop and then you can see the correct temperature. So this is how the temperature sensor, or in general any sensor, works. Now let's shift to the ADC. So ADC stands for analog to digital converter. So here in our board, basically LPC1768 what I'm using, it has two ADCs, and here again the analog input has to be given to the pin of a microcontroller. Here again that specific pin has to be configured to work as an ADC, not as an GPIO pin, which will again do through the PINSEL register. So let's start with the demo of the ADC. As everyone knows, ADC is analog to digital converter. So you need some analog input to be given to a embedded system. So in this demo, I'm again using our GSAS LPC1768 board, and the board has onboard potentiometer. So as you can see on the display, and through that potentiometer, I'm giving the analog input to the on-chip ADC of LPC1768 that will convert that to the digital data, and the digital data can be seen on the onboard LCD display. So here again, because the input is fed to the analog input channel, so the specific pin has to be configured to tell to the controller that it has to be used as an ADC input, not as a GPIO. Again, we do it from the pin select registers. So now let's come to the software part. So in this, now I'm building the project, and after building the project, I'll just download it, right? And after downloading, you should be able to see the output. So now when I vary the potentiometer, you can see on the display, it will change. So this is a 12-bit ADC. So you can see from 0x000 to 0x FFF. So if you rotate the potentiometer, you can see it go up to FFF. And if I minimize, it goes up to 000. So in today's video, you saw how it is easy to use the sensor-rated application or develop the sensor-rated application or any ADC related project. It's very easy. Only thing is the prerequisite is you should know about theoretically how ADC works and how it is basically can be programmed in software through the microcontroller registers. Hope today's demonstration showed you how it is easy to develop a code for even a sensor and even an ADC. So I would encourage the embedded learners to go ahead and try and program these examples. Thank you and stay tuned for more videos. See you soon. Bye-bye.